Example 1 here on the quotient rule is taking a look at using the quotient rule. And we've been given y equals e to the x over sine x, and we're simply asked to find dy by dx. Now here, before we actually find dy by dx, let's just define what u of x is and what v of x is. And in this case, remember, for the quotient rule, u of x is the numerator here. So that's e of x in this case. So u of x is simply e to the x. And remember, v of x is simply the denominator. And in that case, that will be sine x. And remember, when we're using the quotient rule, we also need the derivatives here of u of x and v of x. So let's just differentiate each of these with respect to x. So u prime of x, well, if you differentiate e to the x, that's simply e to the x there. And if we differentiate here v of x to get v prime of x, well, if you differentiate sine x, we simply get cos x. That gives us cos x. And now all we need to do now is find dy by dx using our formula. So therefore, dy by dx here is simply found using the formula of v of x times u prime of x. So v of x here is going to be sine x times by u prime of x. So we're going to get e to the x times by sine x. So e to the x times by sine x. Okay, and we minus now u of x times v prime of x. And in that case, that's going to be e to the x times by cos x. So that's minus e to the x cos x. Okay, and this is all divided by v of x squared. So if v of x is sine x, then if we square that, that's simply going to be sine squared x. And that gives us our denominator here, so that's sine squared x. And at this stage here now, we can go on to simplify this a little bit. So in this case, we can factorize an e to the x out here in the numerator. So we're going to get e to the x bracket sine x minus cos x here. Okay, so sine x minus cos x. And again, this is all over sine squared x. It's all over sine squared x here. And then finally, if we think about splitting this up into two fractions here, we could write this as e to the x times by this bracket here of sine x minus cos x over 1 times by 1 over sine squared x. And in that case, using the fact that 1 over sine squared x is equal to cosec squared x, we can write this as e to the x bracket sine x minus cos x times by cosec squared x. Okay, and that gives us the solution there to example 1. Example 2 here on the quotient rule is using the quotient rule, however this time we also need to use the product rule with it. Well, if we let y equal x squared minus 1 times ln of x, all divided by cos x, where x is measured in radians, we want to find dy by dx, and then go on to verify that there's a stationary point at the point 1, 0. So, in this case again, let's identify what u of x will be and what v of x will be. And in this case here, if we write this up here, u of x is simply going to be our numerator, which is x squared minus 1 times by ln of x. Okay, and our v of x here is simply going to be our denominator, which is nice and straightforward. That's simply cos x. We have cos x there. Now, what we might notice here straight away is we have a bit of an issue because with our u of x here, this is written as a product here of two functions. So we've got x squared minus 1 times by ln of x. And this is why we require the product rule here. So we need u prime of x, but to find u prime of x, we will need to use the product rule. So we'll come back to this in just a moment. Let's quickly find v prime of x. So v prime of x here, well, what's the derivative of cos x with respect to x? Well, that simply gives us minus sine x. Okay. Now, we want to find the derivative of u of x here. And in that case, we need to use the product rule. And what we can do here is split this up into two functions. So if x squared minus 1 is a of x, so a of x here is my x squared minus 1. And my b of x is the natural logarithm of x. That's ln of x. In that case here, again, what we need to do is find the derivative of each of these, and then we just need to apply the product rule. Okay, so in that case, a prime of x here is simply going to be 2x. The derivative of x squared minus 1 with respect to x simply gives us 2x. And again here, b prime of x is simply the derivative of the natural logarithm of x, which gives us 1 over x. Okay, and here now, all we simply need to do then is apply the product rule. And remember, for the product rule here, it's just going to be ax times by b prime of x plus bx times by a prime of x here. So in that case, what we obtain then, for u prime of x here, and hopefully we will have just about enough room, it's going to be 2x times ln of x. So 2x times ln of x. So that's a prime of x times b of x. And again, we just repeat that here with a of x times by b prime of x. So that's going to be x squared minus 1 times 1 over x, which gives us x squared minus 1 over x. X squared minus 1 over x there. Okay. So now we have u prime of x and v prime of x, we can simply apply now the quotient rule. So therefore, finding dy by dx here, what would that simply be here? Well, in that case then, this is going to simply be v of x times by u prime of x. So that's going to give us cos x times by this expression here. That's 2x ln of x plus x squared minus 1 all over x. Okay, and now we minus here u of x times by v prime of x. However, notice v prime of x is minus sine x, so if we minus that off here, well, that's already a minus, it will become a plus here. So that's going to be plus sine x here, it's going to be plus sine x here of this expression here. So x squared minus 1 times the natural logarithm of x. Let's put that in one bracket here, x squared minus 1. So the natural logarithm of x there. Okay, and this is all divided now by v of x squared. So here, v of x is cos x, so if we square that, we get cos squared of x. Okay, so what we've done now is found dy by dx, but we also need to verify that there's a stationary point at the point 1, 0. So in that case, what we're saying here is when x equals 1, dy by dx here should be equal to 0. So if we substitute x equals 1 into dy by dx here, we should obtain 0. So when x equals 1 here, all we need to do is simply substitute that into here. So in that case, what we get then is cos of 1. So we get cos of 1. Well, here, the natural logarithm of 1 is 0. So in that case, this whole expression here, well, this 2x times the ln of x will be 0. And in this case, 1 squared minus 1 would also be 0. So this whole bracket here simplifies to be 0. Okay, so that's cos of 1 times 0. Plus now, we have sine of 1. So sine of 1, and remember, x is measured in radians. However, in this part here, we have the natural logarithm of 1 again, which will be 0. So it's going to be sine of 1 times 0. And then finally here, we're going to have cos squared of 1 here. Okay, so cos squared of 1. And if you evaluate this on your calculator, what you'll find is this whole expression here is simply equal to 0 there. Okay, so therefore, as dy by dx is equal to 0 when x is 1, that verifies that there is a stationary point at x equals 1. Okay, so therefore, we give our conclusion here. So therefore, there is a stationary point when x equals 1, or at x equals 1 there. Okay, and we've verified that there. And that gives us the solution to example 2 there.